Hello everyone, it's me Abhishek Thapa. I'm currently doing intern on Let's Grow More at IT company. I have successfully completed the beginner level task number 1 named as Iris flower classification. This in this project I have used following various machine learning algorithms. There are three families of the iris flower. There are also there are three species of iris flower, that is iris versicolor, iris setosa, iris virginica, which can be classified based on their sepal and the petals length as well as the width. I have used the data set of the iris data set from the kaggle.com in this project. Let's dive into project. Importing the important libraries like pandas, numpy, matplotlib, c1. Loading the dataset using the read underscore csv. Let's see the shape, data types, the length, info, and the statistical properties of datasets. These are the very easy portions. You all know about this. Also, the beginner will clearly understand about this. So I am not describing this too much because this is my first video, and I don't want to make this video long because I already made two videos long, and I can't upload it in YouTube. So I'm making this a little bit short. And now second step, data pre-processing, where I handle the missing and the noisy data. For missing data I have used the is and methods for checking if is there any missing values in our data sets. For the noisy datasets, I have gone through this approach. I visualize the minimum value and the maximum value and the average value, and from those results I have analyzed that there is the minimum and the maximum values of each attributes are not much deviated from their average value. So we can conclude that there is no any noisy values in any tuples. Also, there is no any missing value, so our data is clean. Now let's go to the data exploration and analyzing of the data. Firstly, I have used the histogram. Yeah, I have used the object oriented approach of the matplotlib library, where I have plotted the four histograms. You can go through this also yourself. I have plotted the four histograms, so you can look this way. And I have plotted the scatter plot for length versus width of the sepal, also for the length versus width of the petal, also, and the sepal length versus the petal length, sepal width versus the petal width. You can go through the code. I'm just explaining the conceptual and the conceptual and the informative informative knowledge that I have used for tackling this iris flower classification problem. And this is the correlation matrix and the heat map. I have plotted the heat map also using the c1 library. Box plot, for box plot I have also used the c1 library. You can see this, and I also visualize the single box plot using the c1 library. And finally I have plotted the pair plot using the c1 library, which allows us to plot the pairwise relationship between the various variables within a data sets. Through the pair plot we can get huge information about the relationship between the various variables within our data sets in a single picture. So from the data exploration analysis, we can analyze that the iris setosa, that is represented by this blue color, are linearly separable from the other two species, and the other two remaining species are not linearly separable from each other. Now in step 4, I am gone through the data splitting, normalization, standardization, encoding, that is the handling the non-numeric data. For data splitting, but before splitting the data, I have stored the three tuples of our tuples from our iris data sets, iris dataset, in order to in order to use those three data tuples to predict uh, to be predicted by our final constructed model on on-scene data. For making this data on-scene, I have removed these three tuples from our original data sets, that is iris data sets. So initially it was 150 comma 5, and I have used three of them with each of which each of which represents the distinct classes. So there will be now 147 classes, and I have removed the index 32. Look, you can look, lock 32 I have used, I want to use, or I will use in the future for the prediction, of prediction on unseen data by our constructed model. So you can go through this, and I have you making the xy features. This is very normal things for the beginners also. Now x has the numeric values, but y has the categorical values. So we need to we must encode the categorical value into the numeric value, so the machine can understand those numeric values. So for this we use the label encoder, and you can see I have imported like this. You can go through this, and so the categorical data is converted into the 0 1 1. This is the numerical data, and here 0 is iris setosa is encoded as 0. That is 0 value will represent the iris setosa in the species attribute. So iris versicolor will represent the one. I have also plotted here, and by plotting, by appending the encoded species into this original data sets, I have confirmed, and I have drawn this conclusion also. Now preparing the training in the datasets and fitting to the model, I have used only the random forest classifier uh, for quick visualization and quick understanding of understanding the whole process of machine learning, for tackling this problem. Later I have used all the six other classifiers for the prediction. So stay with me, uh, or you can go directly to at the end of the video to watch other algorithms, how I used other algorithms in this in for the classification purpose. Sorry, my English is a little bit weak, so please cooperate. And for step 6, I have evaluated the models, and this is also the easy person classification report, confusion matrix, accuracy scores, and I have plotted the confusion matrix into the heat map for nice visualizations. And making prediction on set data, previously I have separated the three data tuples: preds data 1, preds data 2, and preds data 3, for making the prediction. So now our model will predict mm, our model will predict constructed model will predict on these unseen data. And look, first data, that is 5.2, which is represent, which has the species as iris setosa, and our model is predict on that test tuple, or prediction predicted tuple as a iris setosa. So who our model corrects correctly. So similarly goes with the other two test tuples, or that is the unseen tuples. Now again our model came up with the correct class level. Now for improving our model, changing the n estimator here, you can go through various heat and trial, uh, and maybe some classifiers, by changing their estimators, their accuracy can be improved and enhanced. But in this case, there is no changes in accuracy. So I use another approach, that is the seed parameters, by setting the various parameters of the seed value. Somehow accuracy improved, and also it reaches to 1.0 when the seed value is 2. Now for saving the model, I have used the typical library, and dump is used to save our model, and load method is used to load that load that saved model. So by using those loaded and or saved model, we don't need to rerun and retrain our model. Now finally I have try out this tackle out this problem using other classification algorithms, and you can go through this code for building for building, training, and constructing the model in a single iteration, in a loop. So I have created the model. So in a single code, I have done this all processes. You can go through the code. This video is becoming so long, so I am just skipping these portions. I have written score and predict, which is a nested dictionary, in order to get multiple return values from our function. So, and I have extracted, trying to extract the data from the return dictionary, like I have extracted the score dictionary and predict dictionary, and go through the list and the values, and finally I have plotted plotted those extracted information into the data frame for clear understanding in a single picture. So now I have arranged in descending order, and just for clear understanding, I have removed the index. And now finally I have completed my task successfully. Thank you so much for watching this video. Please like and subscribe my channel and keep supporting. Thank you so much.